Okay, so correlation is when things are correlated, which means they connect together. So what do you think of hours you study and your test grades? Do you think that would have a correlation with each other?
Depends on
Not really, no.
Depends which class.
Yes, it should have a correlation. It should. The hours that you study and your test grade should be correlated. What about shoe size and your test grades?
That should not be.
That shouldn't have a correlation with each other.
So
So
is it just like a relationship?
a relationship. There has to be some kind of connection. Usually we call it a cause-effect relationship. You know what I mean when I say that? A cause, something causes an effect on something else. Okay, so correlation can be either positive or negative. So if I think about this one example, the money you make and the hours that you work. Okay, so what do you think? The more hours you put in at your job, you should make more money. That is called a positive correlation. Can you think of an example in life that would have a negative correlation? I'll give you one and you can see if you can come up with another one. The temperature outside and sales of hot chocolate. So what do you think about that? If the temperature increases outside, what do you think is going to happen to hot chocolate sales? They would go down. So this would be an example of negative correlation. Is there anything else simple you can think of that would be a negative relationship with each other?
Hot weather and the sale of winter clothing.
Yes, that's a copycat of mine. Almost. What about hours on device and test grades? What do you think that would have? Okay. Hours on a device doing not schoolwork.
What if real are schoolwork?
Yeah.
Okay. Selective here. An R value can be between the scores of -1 and +1. Okay, so if two variables, this is just a number line between -1 and 1. If two variables are strongly connected, it'd be closer to the 1 numbers. And it doesn't matter if it's 1 or -1. This would show you that something is strong, the closer you are to that. So what do you think if it had a weak connection? Where would you kind of have your R value? So, right? The closer you are to one of the n numbers, the 1 or the -1. Okay? Okay, but we're going to examine our chart here. We're going to have an R value chart. Can you grab your formula sheet? Okay, so this is the correlation. These are the R values. Okay, so first of all, this n means your sample size. So if I have if I took the sample of 4 of you and I said, how many hours did you study? And I look at your test grades, okay? That means I've only studied with 4, I've only taken 4 of you as my sample. Okay? As you get more and more of a sample, you need less evidence to show you that there's a correlation. So this R value isn't just a set in stone number. It depends on how big of a sample you take for your data. Okay? And remember, we talked about studying the hours of people on our students have on their phone, and we took a small sample size of our class. Okay? The more and more students you take, like if I took every single student in our school, that'd be a better data sample. Okay. So n is the sample size. As n increases, R doesn't have to be as big. So as the n increases, our R doesn't have to be as big to show this evidence that there's a connection. The correlation is that connection piece. Okay, my next question talks about, well, what about a sample size of 1? So do you notice how there's no 1, there's no 2 or 3 on here? So if I'm doing a sample with people or whatever, there's just not enough evidence to do anything with. If you just look at Gabe's score, is that going to tell me anything about a general population? No, because you're just one person. It's not enough to even make a correlation with anything. You're not a big enough sample. Okay? So it's just not enough of a sample to just make any conclusion. Okay, so this is what you do with the chart. You ready? We're going to go to a sample size of 22. Okay, can you go to your chart to 22? And then at the top here, that's got this 0.05, 0.01, and then there's this number and this number. It always has that at the top. It has a 0.05 column and a 0.01 column. Okay, here we go. Is your R value bigger than this one? The R value, 0.58, is it bigger than this? Yes. Is it bigger than this? Yes. I'm bigger than that one? So here's my conclusion. 0.01 means there's a 99% chance of correlation. There's a I'm 99% certain there's a connection with these variables, whatever it is, hours studied and test grades. I'm 99% sure that my data is showing me there's a connection. Okay? Okay, here we go. I need you to look up 35. I need you to look up 35. Because 100 minus 0.01, like 100% minus that is 99. Okay.
I can use the 0.505.
I will show you in the next example. If I'm bigger than this, but then I'm also bigger than that, I take that one. Okay, ready? Look at your 0.36 number. I don't care about the negative. The negative just shows me the relationship, direction. Okay, 0.36. Am I bigger than this one? Is 0.36 bigger than that?
Yeah.
Yes. Is 0.36 bigger than that? No. So I can't go there. So I can only stay here, which means I am 95% certain. I'm 95% certain that there's a correlation between these variables.
So the negative doesn't.
No. The negative is just showing you which way the line would go if you graphed these data.
You're gonna have to go.
No. This is just a positive and this is just a negative. So I don't care about the negative, it's just showing me that relationship of the variables. Okay, ready? 50. Go to 50 on the chart. Okay, are you bigger than this number? No, and you're obviously then not bigger than that one. So there's going to be no correlation between these data. There's no evidence of these variables being connected.
So is it always one of those three options?
You're either this, or this. Yep. Okay, so if you're bigger than everything, it's 99. If you're bigger than this one, but not that one, 95. And if you're not even bigger than any of them, not big enough. Okay, so we're going to show you how to use this formula, and it's probably the craziest formula you'll learn in high school. It's got some stuff in it. Okay, you ready? What do you guys think about selling a house? The area and square footage of this house and the price of this house. Do you think there would be a connection between how big your house is and the cost of this house? Yes, there's going to be a connection. You know what I put? Prince instead of price. Isn't that nice? Okay. So, there's a bunch of stuff in this formula. Look how crazy it gets. What are you going to use from your formula sheet here?
You're only gonna have one of these questions on there?
Yep, because it takes a long time. Okay, so let's divide and conquer. Okay. Will, Jared, Naya, you're going to do, what is this x value times y value? So this times this, get the numbers here. Okay. Maddie, Gabe, and Aiden, I need you to do this column. You're going to get me all the x squareds. So like, what is 15 squared? Got it?
125. No, 225. You know.
Caden and Anderson and Selena, you're going to do y squared, please. Thank you. And what does this symbol mean at the bottom here? This like weird E. Do you remember that symbol at the bottom? It means to sum. So when you are done, you need to add up your column. Got it? You're going to add it up. So we're dividing the work here. Got it? Okay, so I did this one, so you guys can do this. I added up this column, so I got a 165. This number here, the 165, would be the summation of all the x values. That's what my column was. And I got 1334 on that, which represents what? The sum of all the y values. Okay. Do you guys,
We have the sum.
Do you guys want me to write them all down, or should I just write the sums down? Is that okay? Okay, so you three over there, did you get the same number as the sum? Ready? What are we doing?
29,
29.
29,611.
I don't even know how you said your number. Okay, but all three of you got the same. I like that. Okay. Okay, so you three in the middle, let's see if you all got to the same 38,
Confirm.
55. Like that?
Yes.
All three of you. Amazing.
Yeah.
And the last three of you.
Yes.
201?
41,000.
Like that. Yes, yes. Woo! All three of you in each category. Amazing. Okay. So this is the sum of xy. This column is the sum of x squared values. And this column is the summation of y squared values. Okay, everyone's good with what we have? And the last thing I need to know is the n. The n is the number of pieces in your data. How many houses did we have in our data? 1, 2, 3, 4, 5, 6, 7, 8. Okay, like the sample size of this. We had 8. Okay, here we go. You ready? It gets wild. N, 8 times the sum of the xy column, which is 29611. Subtract the sum of the x column, 165, times the sum of the y column, 1334. Good?
Yes.
Divide by the square root of, ready? Bracket 8 times the sum of the x squared number. So 3855 minus, careful here, do you understand this is different? The sum of x squared, and then this is the sum of x squared. You get it?
Yeah, they're different numbers.
The sum of x squared, got it? Sum of x squared, this one, and this is the sum of x.
So it's stupid.
Squared.
Because they should be the same.
No, because this is the sum of the x squareds, and then this is the sum of x getting squared.
Oh, really?
Oy vey. So that is what? 165 squared, like that. Do you see a difference?
Yeah.
Everyone's good with that? This is the sum of the x squared column. This is the sum of the x column, and then I square that number. Okay. Times, we haven't done any of this. So n, so 8 times, this is the same idea, the sum of the y squared column. So that's the big number, 241394, minus the sum of the y column squared.
It helps when we say them at different speeds.
I know, that's what I'm trying to really do. Okay, then you just hope and pray that you type it in right. Good luck to you. Yeah, actually, I do. No, it's not done even. Because here's what it is. So find the R value. So we did that, 0.717. And now we have to interpret the results. So interpret the results. So here's our R value. And remember what we did? Our sample size was 8. Okay, so we're going to go to our chart. Okay, so here's my chart. When I go to 8, correlation chart, 8.707 and 0.834. Okay, so here's our R value, 717 here. Are we bigger than this? Yes. Are we bigger than this? No. So I'm only this. So I'm 95% sure that there's correlation between these variables. I'm 95% confident that a house square footage and the cost of the house, there's a connection. Okay?